Assalamu alaikum and welcome to Abdullah Sir Science class. In today's class, we are going to learn about the difference between uniform and non-uniform acceleration. So without wasting much of our time, let's get started. Welcome back. In uniform accelerated motion, the acceleration of that object or the car is constant. The word uniform refers to constant acceleration, right? Let's see. That means non-uniform accelerated motion may be referring to not constant acceleration. That means acceleration is not same every time. Let's see it briefly. Let's have a look here. If the rate of change of velocity remains constant, that means if the velocity, what acceleration is? Acceleration is change of velocity with respect to time. If the velocity is changing but changing equally with respect to time, then the acceleration is uniform. Let's see what's here. If the rate of change of velocity remains constant, that means the change what is happening in velocity is constant, then the acceleration is uniform. Understood? Right? That means for the acceleration to be uniform, the velocity change must be equal at every interval of time. Let's see again. There is an example present here. Example of uniform accelerated motion includes a ball under a free fall, right? If a ball is falling freely, right? If anything falls freely, it falls down with an equal change in velocity, right? 9.8 meter per second square. What do you mean by this acceleration? This acceleration has a fixed constant value. It is telling us that this is uniform. It is not going to change. It is constant, right? If it is uniform, right? If this acceleration is uniform, then the velocity change may be equal at every interval of time. Let's understand this. The ball, when it is falling down, the initial velocity by which it is falling down is 0, right? The ball is about to fall, and at that time the velocity would be 0. And when the ball is falling down, right, in 1 second, okay, what this acceleration is referring to? Acceleration is the change in velocity. So 9.8 meter per second square is nothing but in 1 second the velocity is changing at a rate of 9.8 meter per second. If it is 0 at time 0, if initial velocity is 0 at time 0 second, and after 1 second the velocity would be 9.8, alright? And if 9.8 meter per second. Similarly, if after another second, that is for time t is equals to 2 seconds, the velocity again will change. How much? 9.8 was previously at 1 second. Again the velocity will increase to 9.8 more, so it will be 19.6 meter per second. How much? 19.6 meter per second, right? So that means acceleration is telling us clearly that after every second the velocity change, the change in velocity would be 9.8 meter per second. After 1 second it will be 9.8 meter per second. After 2 seconds it will be double of that. After 3 seconds it will be again 9.8 added, right? So that is uniform acceleration. If the acceleration is positive, this gets added, and if the acceleration is negative, this gets subtracted. Alright, so let's have a look at non-uniform acceleration, right? Have a look. If the rate of change of velocity with time is not constant, if the rate of change of velocity is not constant, right? Not constant in the sense not fixed. The velocity is changing at every interval of time, right? But not changing equally. So if the velocity is changing but not changing equally with time, then that acceleration is referred as non-uniform acceleration. Here the acceleration value is not fixed with time. It's not constant. It's not constant, right? With time. So it changes with time. Why? Because the acceleration is non-uniform. Alright, so acceleration is not constant. Why not constant? Because the velocity is changing but not changing equally with time. Alright, This is the clear difference between uniform acceleration and non-uniform acceleration, right? Let's have a look at the example. Example of non-uniform acceleration is a car accelerating on a straight road with traffic, right? What happens with the traffic? That because of the traffic, the velocity is continuously maybe changing, but not changing equally, right? Sometimes you have to brake and sometimes you have to move again, right? So a falling object or the car accelerating on a straight road is the example for non-uniform acceleration, and a car moving with on a straight road but with the traffic is the example for non-uniform acceleration. All right. So let's have a look at certain examples. So to understand much better, we have the calculations to perform to understand the difference between uniform and non-uniform acceleration. Let's have a look. Here we have a car, right? Consider this to be a first car. Initially, the first car is at rest. All right. And if the car is at rest, and after 1 second, consider the interval we are talking about, the time interval to be always 1 second for simple calculation. All right. So let's find the acceleration between this car after 1 second. I mean, the same car has moved from this position to this position, right? Let's find the acceleration. Acceleration is equals to rate of change of velocity. Final velocity here, if we are calculating the acceleration here, then we have to subtract the final velocity v2 minus initial velocity v1. So v2 minus v1. v2 minus v1. What is the time interval we have? 1 second. Let's substitute them in the formula. v2 minus v1 is 5 minus 0, all right, by 1. The answer is 5 meter per second. All right. For simple calculation, we took the time 1 second and it has become easier for us. 5 meter per second square, right, is the acceleration's SI unit. Now that we know that the acceleration is 5 meter per second square here, let's find out the acceleration of the same car, right? In the second interval, the velocity change is from 5 meter per second to 10 meter per second. So let's find out the change. The change is how much? v3 minus v2. For this calculation, v3 minus v2 by time period, right? Time is how much? 1 second again. v3 minus v2, v3 is 10 meter per second and v2 is 5 meter per second, right? What is the time interval? 1 second. So what is the acceleration? 5 meter per second square again. Right. So we understood, sir, here also the acceleration, the change in velocity is 5 meter per second in 1 second, that is 5 meter per second square is the acceleration. Same. The change in velocity is changing. See, understand the concept. Velocity is changing. The acceleration says that velocity should change. So velocity is changing from 0 to 5, 5 to 10 and 10 to 15. In each second, it is changing equally at an equal interval of time. Then the acceleration is said as uniform acceleration. Let's see, if you calculate the acceleration here, you will get 5 meter per second square again, right? So we understood that acceleration for this first car is uniform because every time the acceleration is same. All right, uniform, right? Acceleration is uniform acceleration. Okay, now let's have a look at the this second example and third examples. All right, for that let's try to calculate. Here the velocity is 0, that means the car is at rest, second car, and this second car is at rest and the car has changed its speed from 0 to 5 in 1 second. So acceleration would be 5 meter per second square, right? You subtract final minus initial, you will get the acceleration. And if we subtract the acceleration here, 15 minus 5, and it will be but 10 meter per second square, right? The acceleration is 5 to 10. Now let's understand the acceleration here. The same car after second, that is in third second, has increased from 15 meter per second to 25 meters per second of velocity, which is nothing but 25 minus 15 becomes 10 meter per second square. All right. So this means throughout the journey, the velocity of the car is changing but not changing equally with time. That means acceleration is not constant, right? It is non-uniform acceleration. Non-uniform acceleration. All right? Right? Ignore my handwriting. All right? That's good. So let's have a look at the third car. We have velocities. 30 meter per second, 20 meter per second, 10 meter per second, 0, right? What do you understood with this? Velocity is decreasing. Sir, in previous example, the velocity was increasing. Here, the velocity is decreasing. Let's see. Velocity has decreased from 30 meter per second to 20 meter per second, which is, if you subtract V2 minus V1, you will get minus 10 meter per second square. Here, the acceleration is not positive. It is negative, right? Let's have a look at here. V2 minus V3, it is again minus 10 meter per second square. Sir, acceleration is again negative. Let's have a look here. 0 minus 10 minus 10 meter per second square. All right. So continuously the third car having the constant change in velocity. So constantly the velocity is decreasing. 10 meter per second in 1 second reduction, and in the second again 10 meter per second is reduced, and in the third second it is reduced again. So every time the velocity is changing equally. Acceleration is uniform, right? So it's uniform acceleration again, right? Uniform acceleration. I hope you have learned about uniform and non-uniform acceleration clearly. I hope you have also understood that acceleration can be negative and positive, right? So I have a question for you. You guys have to calculate the acceleration of fourth and fifth car, and also let me know whether the acceleration is uniform or non-uniform, and also get me a clear picture whether the acceleration is negative or positive, right? Thank you so much. That's it for today's class. Don't forget to hit like and subscribe button, and don't forget to share if you find it valuable. Thank you so much. Assalamu alaikum wa rahmatullahi wa barakatuh.